So I grew up on a dairy farm in southern Illinois, and one of the things that my dad would like to do often is take a ride on a Sunday. And often we would end up at the airport in St. Louis, Missouri. And we'd sit there and we'd watch planes go by, and that was pretty fascinating to me.
For Karen Tolley, that interest in flight grew through college and led to a successful research and academic career.
Right? Yeah, we got a couple wires here.
Today at Pennsylvania State University, Dr. Tolley heads two research centers that study heat transfer in gas turbines: the Experimental and Computational Convection Lab and the Steady Thermal Aero Research Turbine Lab, known as the START Lab.
These are bigger mountains here, in roughness in terms of this as opposed to this. The heat transfer in a gas turbine is so important because the hot gases exiting the combustor in a gas turbine are higher than the melting temperature of the downstream turbine airfoils. If you don't cool those airfoils, the airfoils will melt, and obviously the engine won't work.
The START Lab is one of the country's most advanced turbine testing labs. Researchers are testing new cooling methods on turbine hardware.
There's no other lab right now that can meet the rotational Reynolds numbers and the Reynolds numbers needed to simulate a true gas turbine engine. So really all of the experimental work that we're trying to do takes place in this small section here, but you need all of this piping to get the right flow conditions for that test turbine.
Tolley built her first lab at Virginia Polytechnic Institute and State University in 1999. There, she discovered a way to reduce the damaging effects of horseshoe vortices in gas turbines.
There's quite a complex vortical pattern that develops because of how the boundary layer interacts with the leading edge of an airfoil. It's called a horseshoe vortex. We came up with a novel design of a fillet that we could put on the front of an airfoil that actually helped to reduce the heat transfer and reduce the aerodynamic losses.
She has done a lot of work that has impacted our advanced engines, and there's actually concepts and technologies that she's worked on that are now flying today in the most advanced fighter engine.
The head of Penn State's Mechanical and Nuclear Engineering Department, Tolley is a role model for students. She makes a special effort to reach out to women.
So air is like in and out of.
Yeah.
I met her in my undergrad, and just the way that she talks about gas turbine engines, and you can tell that she really loves what she does, and she's very well respected in the field.
And then he had the next one.
She's the only reason that I'm in grad school.
Tolley herself had no such role models in college.
My girlfriend, who was in chemistry class with me, suggested maybe I think about engineering. So at Christmas, I went home and I decided I needed to investigate this engineering thing and find out what that was. So I called McDonnell Douglas one day, which is now Boeing in St. Louis, and I asked the operator if they had an engineer on staff. And she laughed at me and said, there were many engineers on staff, and who would I like to speak with? And she put me in touch with just the right person, because he described his job to me, and I thought that sounded incredibly fascinating. And that's what made me interested in engineering.
Tolley hopes to help younger students develop enthusiasm for science and technology. She started Engineering Ambassadors, a Penn State student outreach group that visits high schools across Pennsylvania.
It continues to be important for us to educate high school students, teachers, guidance counselors, as well as grade school students. We have to let people know what we do and the excitement that you can have in having a career in engineering.